Okay, let me erase this up. So today we're looking at horizontal and vertical asymptotes, which something you should have heard of. It may have been a while since you've seen it. An asymptote is basically, it's an imaginary line on a curve that your curve will never reach. Like if we saw we did exponential functions, like if we grabbed exponential decay, right? It'll go down over time. It'll keep getting smaller, but it will never reach a certain point. Like if I said you had $100 and you gave away half your money every day. So you'd have $100 at the beginning, and then 50, and then 25, and then 12 and a half, 6 and a quarter, and you would keep splitting in half, and it would keep getting smaller and smaller and smaller, but you'll never hit 0, right? Mathematically speaking. In real life you would, because you can't break down money so much. But in math, we can't. So we say we approach a certain number, and that's our asymptote. So we mark it off with a dashed line, something we get close to, but can't ever reach. Okay. So a rational function, here's our definition of it. It's just any function given we have one part of the function on top, one part of the function on the bottom, and our bottom part cannot equal 0 because we can't divide by 0. That's undefined. Okay. So every one of our rational functions is going to have a vertical asymptote, and that's where we take our denominator and set it equal to 0. Right? So I want to know, just like we said, if b equals 0 doesn't exist, it's not defined at that point, so that becomes a point we can't reach. We can get close to it, but it can never actually equal 0. Okay? So that part's not so bad, depending on how difficult your expression is in your denominator. All right, your horizontal asymptote. This you might want to pause, copy this down. This is kind of a big deal. This is like all of your answers in this 3 bullet points here. Okay. So for our horizontal asymptote, one of 3 things has to be true. Right? The degree of the top is either going to be greater, less than, or the same as your denominator. So remember, your degree is, you can think of that as the highest exponent. Okay. So you look at your whole equation, like if we come down here, we see on top we have x to the 3rd, on the bottom we just have x, so that's x to the 1st. So we would say the degree is higher in our numerator because 3 is more than 1. Okay, so that's what we look at. Everything else doesn't really matter. All we care about is the biggest exponent on top and on bottom every time. Okay, so we look at it. We say if the top degree is higher, then our answer is no horizontal asymptote. We just say none, does not exist. Right? If the degree on top is less than what's on the bottom, then we say the horizontal asymptote y equals 0 every time. Doesn't matter what your degrees are. If your degree on the bottom is higher, then your asymptote is y equals 0. So, right? Okay, and then the one where you have to do a little bit of work, and I should have said this before, I told you to pause it. If they have the same degree, like our 3rd example here, we see x squared and x squared, then the asymptote is not, it's not a over b. It's close to that, but not exact. Is the leading coefficient of a over the leading coefficients of, I spelled it wrong. You get the idea. Leading coefficient of b. And I sort of ran a room. Okay. So what leading coefficient means is you look at your highest exponent, and I just look at what are the coefficients of those 2. So in this case we have 1 over 2, so we'd say the horizontal asymptote is at y equals 1/2. Right? So whatever your coefficient is for that highest degree, you just write out that fraction, piece of cake. Okay? Simplify it if you can. But that is only if we have the same degree top and bottom. Otherwise, your answer is going to be none or y equals 0. All right, so let's try a couple. So x to the third over x minus 1. So we said for our vertical, I want to know what value will make our denominator equal 0. So x minus 1 equals 0, and then solve for x. So plus 1 to both sides. Let's see, that gives us x equals 1. So our vertical asymptote is that x equals 1. That's it. That's all there is to it. Take whatever's on the bottom, set it equal to 0, solve for x. If it's a quadratic, and we'll see, actually, we'll do an example of quadratic. We'll come back. Okay. How about our horizontal? So I see x to the third on top, x to the first on the bottom. So I go to my notes. I see that higher degree is on top. So my answer is no horizontal asymptote. We can practice spelling this because that's a hard word to spell. Okay. All right. So our second example, same idea. So vertical. I take my denominator and I set it equal to 0, and then I solve for x. So minus 1, so we get x equals -1. So that's my vertical asymptote. Horizontal, really this is the same thing. We have x squared on top, x to the first on the bottom. So since my higher degree is on the top, it's going to be the same answer. So it's no horizontal asymptote for both of these cases. Okay, so really that's about it, right? Horizontal, you just compare the higher degree. For our vertical, we take our denominator, set it equal to 0. Let's see if I can find one. It's a little bit more difficult here. Let's see. Yeah, this is good. Okay, number 4. So vertical, this is one I want to look at because we have x squared minus 2x minus 3. We want to set that equal to 0. So now we have a quadratic, so we think of how do we solve quadratic equations. And since it's just x squared, we can factor. So this is going to be, what, x minus 3, x plus 1 equals 0. Now keep in mind, we're not looking for the, well, we are looking for the factors, but that's not our answer, right? If our factors are -3 and +1, remember that makes our vertical asymptotes the opposite of those, right? What values of x will make that equal 0? So that will be +3 and -1. Okay, so don't forget about that. All right, and then our horizontal, we look at our degrees, and I see x squared on both. So since they're the same, I know I'm going to take the leading coefficient of both. So I don't have anything in front of x squared, so I put a 1 there. And then I'm going to say, what is my ratio of those coefficients? So that is 2 over 1. Or, you know, it should say x equals, and this should say y equals. So y equals 2 over 1, or more simply, y equals 2. So vertical, +3, -1, horizontal, y equals 2. There's my answer. Okay, let's give you one more hint before we send you off here. Because like on number 8, you'll see we have another quadratic, but this time a is -3. And if you're like, wait, I don't know, I can't factor that. I can only factor when a is 1. But then I look, I see -3, +3, +6. Those are all multiples of 3. So we could actually, since we're setting this equal to 0, 3x squared plus 3x plus 6 equals 0. So I can divide both sides by -3, right? So that's going to give me negative 3 divided by negative 3 is x squared. 3 divided by negative 3 is minus 1x. And 6 divided by 3 is minus 2. 0 divided by negative 3 remains a 0. So then we can factor this one, right? Because we divided both sides by negative 3. That way it gets our a back to a nice 1. So that'll be the case. There's a couple of them like this, where a doesn't equal 1, but you can simplify it and then solve by factor. Okay? Now one more thing I want to show you. And this goes back to question number 4. So we said our vertical asymptote was at 3, negative 1, and our horizontal was at y equals 2. Let's take a look at what that looks like on a graph. So we graphed out 2x squared minus 4x over x squared minus 2x minus 3. And here's what we see. So you notice, first of all, it looks kind of weird, right? You can graph all these and you can see all the cool things that rational equations can look like, or rational functions rather. But we see a couple points where it gets close to this line, both on the top and the bottom, but it never actually hits this, what point is this? Negative 1, right? And on the other side, it never quite gets to positive 3. And that's the asymptotes we listed. And then our horizontal, we can see here, right? Like it stops at whatever decimal this is. But over here we see these ones, they extend on forever, but they get real close, but it will never actually touch at at y equals 2. Okay? And that's what asymptotes are. Even though you look at it and be like, no, look, it totally looks like it's touching. It's not, though. It's just very, very close. Okay? There you go. That's what we're looking at. You can graph all of these if you want to double check your answers, but I'd work them out first myself to avoid cheating. All right. Bye.